are available on Zenodo. I uploaded them, so you should be able to get this, and this is all clickable. I am an employee of Semantic Web Company, and it's the vendor of PoolParty software. Maybe you saw our big booth there in the swimming pool blue. The software is called PoolParty. The company, Semantic Web Company, bases its product on semantic web standards. And we, come up with the company name before our product name. So we couldn't call it, we had to come up with a product name. So something, pooling again, different pools of data. So it's for taxonomy management and ontology management. So that's why I'm talking about taxonomy-driven ontology design. And my career is as a taxonomist and more recently into ontology. There was some echo. And then from there, those are components of knowledge graphs, as we will see, and you can build various applications on that, such as search engines, recommender systems, questioning, answering, so forth. And we integrate with some other applications out of the box, Tridian, Docs, SharePoint, Adobe Experience Manager, and then can integrate with other content management systems with our API. And then, at the back end, it's different. It's in ingestion of data. The company is headquartered in Vienna, Austria, but I'm with the US subsidiary in Boston. I've been a taxonomist for over 25 years. So along the way, wrote the book, The Accidental Taxonomist. I have a few copies here. And the most recent edition just came out in November, which has an added chapter on ontologies and a brief mention of knowledge graphs too. And I write a blog called The Accidental Taxonomist. So this is the outline. Some basics on taxonomies and ontologies, what they are and what they're good for. And then the standards and features of them, and then going to different approaches to developing ontologies, and then finally that why a taxonomy can be enriched to become an ontology. So I'm kind of curious to see a show of hands of how many of you feel kind of comfortable about taxonomies, about how creating them and so forth, and how many with ontologies. Okay, sort of even, maybe. I thought there'd be maybe more from ontologies here, and some don't feel confident holding up your hand at all. So I'm, that's why I'm introducing a little bit more on taxonomies and ontologies both. So what are taxonomies and ontologies? And feel free to raise your hand at any time. I mean, at times I might pause after a section, for more questions, but if you want a clarification, just raise your hand. So the approach that I take as a taxonomist who's worked with controlled vocabularies of other sorts, other kinds, is that both taxonomies and ontologies are kinds of knowledge organization systems. And I know there are different approaches to ontologies. You might think of them more as modeling data. But one approach is to think of them all and others as knowledge organization systems, KOS. And that could be any system, and including terminology or classification systems to organize and define and manage knowledge, well, explicit knowledge, which can be written down. And a subset of knowledge organization systems are controlled vocabularies. Term lists, synonym ring, name authorities, taxonomies, and thesauri, which are specifically used for tagging or indexing content for information retrieval. I mean, other knowledge organization systems have other purposes or focuses. Certainly, glossaries or dictionaries have a different purpose, which is to have definitions and terminologies, definitions often with different language translations and their categorization and classification systems, which are very similar to taxonomies, but not exactly. Some of these come from library and information science, but then there's semantic networks and ontologies, which have a different origin, but are coming closer to controlled vocabularies, as we will see. So what is a taxonomy? Now, ANSI-NISO, that stands for the American National Standards Institute / National National Information Standards Organization. So ANSI publishes all kinds of standards, especially in engineering, but NISO specifically those in information science. So that's why it's kind of co-published. And they have standards, especially for thesauri, but they have a glossary in them, defines a taxonomy as a collection of controlled vocabulary terms organized into a hierarchical structure. So it's pretty open and broad with that definition. Of course, then what is a controlled vocabulary? So that's also in the glossary, which is a system of terms that have been enumerated explicitly. It's not just any terms, not just any keywords. And it's controlled by some authority. And all terms in controlled vocabulary must have an unambiguous, non-redundant definition. And that's what's quite different from a dictionary, because you've got lots of synonyms and homonyms and so forth. So it's one-to-one, a kind of concept, a definition, and its term. I also, of course, look up Wikipedia, which goes a little off into that classification area. I mean, a scheme of classification, especially hierarchical, and the organization of things. But it can also organize index to knowledge, and that's important too, such as in the form of library classification or a search engine taxonomy. It's trying to cover everything, so it's not quite as clear. It's almost nice to go to the simplest definition. But I mentioned, it's a controlled vocabulary that we have unambiguous concepts, and then it's also organized into some structure. So those are the two features of a taxonomy, that it's controlled and organized. And then the control is that everything is for a concept, for a thing, not strings, things not strings, string referring to a string of text. And that's important because we're not just controlling words, it's actually the concepts that's behind them. And then putting them into some kind of a structure, usually hierarchy, but we've also seen things called faceted taxonomies where they're grouped by aspects. And now this pair of screenshots here is from the PoolParty software for taxonomy management. And I do want to say, well, of course, we have competitors that do taxonomy management, and it's done the same way. So I'm not just saying, it's only in PoolParty, where you have a hierarchy, the structure, and a selected concept from the hierarchy, selected here in orange in this case. So this is a taxonomy of recipes. And the concept appetizer, when it's selected, then there's a panel to the side. It's actually to the right, not to the left, which shows the controlled aspect, the names, which can be in different languages. Here we also have appetizers in German. Alternative labels are the synonyms. Hidden labels is an option for additional synonyms, maybe to support search, but they might be misspellings or some other kind of deprecated names that you don't want to put into a display. Scope note is a note to refer how it's going to be used in the tagging. It's not the same as a definition. And then there can also be a definition. These are not all required, but this is showing the controlled aspect of a taxonomy and the organized together. And then that's in the back end, managing it by a taxonomist. In the front end, to the end users, they will also see both a controlled aspect and organized hierarchical or faceted aspect as well. We have developed internally a taxonomy for our software product, Help user pages, and the users, when they go into help.poolparty.biz and they want to look up something, they can type it in. Typing in data into the search box then matches against concepts in the taxonomy, even parts of it. And now what's showing here are actually concepts in the taxonomy first, and then the user selects that concept and then goes to the pages or sections of pages actually that have been tagged with it. And it even is showing here the context. Is it in the topics or is it in the PoolParty product details? So that's showing how controlled aspects of a taxonomy are shown to the end user. And the next one is showing there is a kind of faceted search. And I said, so this is topics versus document type or the PoolParty product components. And then you can see, so that was already a facet. And then within topics, you can see there's a hierarchy. It's not really clear with this thin type on the pink, but it's an expandable hierarchy. And again, you can see where something to deal with data also it fits into the hierarchy, and the end user can then, of course, select from this hierarchy display. So the benefits of taxonomy, of course, the benefit of the controlled and the structure, the organized structure. The controlled, one of the main benefits is to bring together different names, different synonyms for the same concept, whether it's coming from the text or coming from the end users. What are they? Different users will call the same thing by different names. So it helps people search by information by different names. And then the classification structure organizes information to a logical structure, and it helps users, as you can see, browse if they're not even sure exactly how to call something. And it also provides context at the back end for the tagging or indexing, whether it's done automated or manual. All right, now moving on to ontology. Are there any questions at this point about taxonomies? Okay, hopefully I made it clear. All right, yes?
When you say classification, is there a difference in the taxonomy world classification? The categorization is different. What are they?
Okay, question between the difference between classification and categorization.
From taxonomy and the ontology point of view.
Yeah, from a taxonomy or ontology point of view. I don't think so. I mean, there is a difference between categorization, classification versus tagging, because the focus is in what category or class does this go into, you know, as a content unit, versus what is it about. And you can have multiple tags that are overlapping on the content. I mean, again, I am thinking about some unit of text content, whereas it can only go into one class. It's sort of a different perspective of it. And classification is often done with auto classification, with machine learning, like looking at the whole document and sample documents of this type, and, you know, having these whatever statistics about it go into a certain class, which is a little bit different from the tagging. But I don't really see a difference between categorizing and classification.
Okay, great, thank you.
Unless anybody else has. Okay, so in ontology, I usually go back to the definition by Tom Gruber, you know, kind of in the modern information and knowledge management sense of ontologies, not philosophy. And then, of course, there's a connection with computer science as well. But the modeling a domain of knowledge with primitives, something, you know, very fundamental, as classes or sets and attributes or properties and relations. And so which include information about their meaning and constraints. And that's also quite interesting, on their logically consistent application. And then Wikipedia and ontology, again, it mentions the same things about categories or classes, properties and relations, about concepts and data and entities. And some other definitions. You know, I started out talking about knowledge organization systems, and I said that ontologies and taxonomies are both knowledge organization systems. But an ontology is something more. It's not just knowledge organization, it's also knowledge representation. And it's based on a collection of descriptive statements. So then these would be in subject, predicate, object triples. So these are other characteristics of informal naming and definition. Again, the types, properties, and relationships, which are then the classes and attributes and semantic relationships. It's also can be considered more of an abstract layer of another knowledge organization system. So it can then connect to, if it's, you know, that abstract layer, connect to taxonomies and other control vocabularies, providing more semantics. And that's where I'm going with the whole theme of taxonomy-driven ontology design. So an ontology is often defined as a semantic model that conforms to our web ontology language, because that is sort of the de facto definition now of ontologies. all right, I made this little model. If you're not it's completely familiar with ontologies, those three features of classes, relations, and attributes. So the classes here I put in blue. We have a class of country, a class of organization, a class of employee, and then of course there are individuals that belong to each. And then there are these relations between them. They're semantic. They're based on what the classes are and how they relate to each other. They typically have an inverse, as I have here, but it's not required. They could go in one direction. And in some instances, they are bidirectional, like goes with or has sibling or something like that. So I have country is home of organization. Organization is headquartered in country. Organization employs employee. Employee is employed by organization. And then the third characteristic is the attributes, which I have here in green. So a country will have a good currency, language. It could have many more. Employee has job title, has email address. Organization has headquarters city. NAICS is North American Industrial Classification System codes, but you could have some other industry classifications. And these could be reusable too, because an organization also has an email address. So these are just some examples, but the way it's modeled is it's just a value instead of yet another controlled vocabulary. All right. Now that was, of course, as a high-level model. If we want to look at with more specific examples, in PoolParty software, we have this demo taxonomy ontology that's all on cocktails. So this comes with, so this cocktail called Cosmopolitan, yeah, the broad or narrow, but then it uses a certain type of glassware, and it consists of a certain ingredient, and is maybe part of yet another drink, and it has other ingredients in it. So that's how we have a model, which actually you can see on our demo. And then, of course, more attributes or characteristics. So martini glass has some other alternative labels and when it was created and a definition as well. Okay. All right, so I've shown you kind of two examples, like the high-level model of an ontology design. Oh, it's my colleague. I told him to take a picture. Yeah. Hey, you can go in the back corner there and get a nice picture of all these people sitting in front of you. So I said this, like this upper level, or is it an upper level, or is an ontology all the the upper level model plus all those instances and individuals? And it kind of depends on your definition of ontology. And where I'm going with the taxonomy-driven ontology is the result is you get the upper level model plus all of the instances as well, the names of specific drinks in this case, or it could be names of people or product components or so forth. So this diagram, there are variations of it. It's even in the ANSI/NISO standard, showing different kinds of controlled vocabularies from a more simpler to the more complex. So a simple term list means you just have the control of ambiguity. You don't, we know what's the most basic control vocabulary. A name authority has usually often named entities, proper nouns. They could be like names of people or names of companies. So in addition to having the names and the variants, the synonyms or alternative labels, there may be some attributes as well, some characteristics such as person. It could be the email address or some employee ID or a birth date or something, or with a company, it could be an industrial classification code. And then a taxonomy, that's where the hierarchical relations and structure is also a defined feature. The synonym control, the alternative labels, is actually optional for taxonomies, but it's highly recommended when a taxonomy is any substantial large size so people can find the concept. It's only if it's a very small one that's not required. Now, a thesaurus has a little more structure to it. There's the broader, narrower relationships, but also an associative relationship, which is the related term, although it's kind of equal in both directions, and it's not anymore, it's very generic, related. And then the synonym control is a standard feature to have that there are these alternative labels, or traditionally they're called non-preferred terms versus preferred terms. And when I refer to the definitions from the ANSI/NISO standard, that standard is specifically for thesauri. And then ontologies, instead of having hierarchical relations and just generic related, they have semantic relations, as I showed in the slide before. And classes are defined because you have the relations between different classes, and then also attributes. Of course, there are other features too, having to do with having constraints and reasoning that can be built in with some other rules, but those three are the most basic. Now, in this is showing like the ontology in this case, if it's over here on the right, it's the model plus the entities. But I'd like to suggest another way to look at it is that the ontology is then the semantic layer that's connecting to multiple term lists, multiple name authorities, and then one or more taxonomies or maybe a thesaurus, so that what we're calling ontology as we model it is a more generic model, and it's linked to taxonomies. And that's where, again, taxonomy-driven ontology design, because you already have taxonomies, maybe, and you don't have an ontology yet, you start kind of bottom up with the taxonomies and modeling the ontology. Okay, any questions at this point? Yes?
On taxonomies, can you have, with it being hierarchically structured, can the same entity show up multiple times in the hierarchy, or is it strict?
Yes, they may. And that's also something different than classification. You know, things can only go in one class. That a taxonomy concept can have more than one broader concept. So it's the same concept. It has the same ID, the same URI, but in a visualization, it can appear in more than one place to the user, so they navigate from one direction versus the other. I mean, it has to be definitely belonging to a kind of each, you know, it has to follow the standards for that. And that's, I mean, it's just, that's the way it can be. With ontologies, when we talk about classes and their members, you can actually set that as whether it's they can belong to both, or it's disjoint, where the members cannot belong to more than one. So there's also that option, but you actually control it in a certain way. All right, so why taxonomies and ontologies? Maybe you know already that there's need, that's why you're here, but you maybe still need to make more of a business case for others. That there's data and content in silos, and it's not consistent, it's heterogeneous, and there's mixture of structured and unstructured data, mixture of data and content, and yeah, the same things having different names and localized meaning, and there's change. And this causes inefficiencies, missed opportunities, poor decisions, and also poor user experience. So the goal is to share data, reuse data, link data, linking content as well with semantic links, having a more unified view. So this can be provided by some kind of data-centric architecture with ontologies and knowledge graphs, which results in better knowledge discovery, better decisions, and better user or customer experience. So what can you do with a taxonomy alone? Because, you know, if you've been working with ontologies, what's the purpose of a taxonomy anyway? It's just, you know, more and more subclasses of a tax. It's the kind of the primary focus is that tagging to content for what it's about. So it's consistent and the retrieval is comprehensive. You don't miss certain content, and accurate. We talk about precision and recall versus just keyword search alone. Precision is the accuracy, and recall is bringing back everything on a topic. Normalization, so that's bringing together different names, localizations, languages for the same concept. And supporting, of course, search, finding content about something, you know, especially having, you know, those search strings then first match to concepts in the taxonomy and their, you know, system of synonyms, which are then tagged to the content. But also supporting browse, if it's some form of the interface, hierarchy, or with even just facets, which allow users to explore too, and not just search and can find content. And that brings us, to that faceted aspect. Many taxonomies now are manifested in a user interface to users with some kind of facets or filters. I will say faceted taxonomy is not all of you can have additional filters too, like filter by date or file format or something like that. But you're used in combination. And in addition to search and browse, then there's a discovery. What is there that we didn't know that was there? And this can be, one of the ways is that content that has been tagged with certain concepts, then you can explore what else has, and you found some content you like, and you see what concepts have been tagged to it, then you can go to that concept and find what else has been tagged to this concept, and then you're exploring, kind of branching that way. Or even just the relationships within a taxonomy, like the related concept relationship. In addition to kind of more proactive search and discovery, there of course can be something you set up as a feed and have curated content or alerts based on preset terms. And then taxonomies are very often implemented within a broader set of metadata. So a taxonomy, you've got these different metadata properties dealing with content. And then there could be one called topic. What's it about? And then you have, a big taxonomy kind of filling in the values for that metadata property. And then when the taxonomy concepts are tagged to content, then they become metadata on the content. But the metadata serves other purposes too. It's not just to search and retrieve. There's just to identify, know better, or do comparison or analysis. What else shares the same metadata, and look at that. And I'll bring, coming back to the classification systems, how they're different. They are especially used for analysis and comparison. So industrial classification codes, every industry is assigned to a classification. And then you can do this kind of, or every company then is assigned an industry classification. And then you can do comparison analysis, statistics about an industry based on its members, what's the total output and production and all that. But if one company is assigned multiple classifications, then it kind of confuses the analysis. Well, how much are they in this industry versus that industry, and they're duplicating and all that. That's why we like to have classifications mutually exclusive, because they are serving a different purpose often, which is for comparison and analysis. Okay, now, great, taxonomies are great. Why extend them into ontologies? Well, there are other things you can do with an ontology and not a taxonomy alone, especially kind of adding an ontology to a taxonomy. Modeling more complex interrelationships, obviously these, semantic relations, which are interesting when you want to kind of figure out how things are related, especially maybe in product approval or supply chain processes. There's more going on. And then also connect to content too. We're just not modeling it for the sake of modeling. Having more complex multi-part searches. So I had said taxonomies are for simple search. I want to find content about blah, this topic. And maybe we can filter this topic and this topic, or this topic in this place. But we're just still, it's what it's about. But if you want to get something, I was even trying to do this. I wanted to find our contacts located in Austin were employed by companies which belong to certain industries. This is this multi-part type of search that you can't just put into a search box. But if these are connected, these are different classes and they're connected by an ontology, you can do that. And even just the exploring of these explicit relationships between concepts, not just broader, narrower, and related. And then searching across data sets and not just content. So taxonomies alone are good for content, but hey, we're all interested in data too. There's a lot of it. And that's brought into ontologies, everything with those, the attributes, which are also called data type properties. There can be a lot of data in there. And then even modeling the semantic relations may be based on data. This may come in originally in spreadsheets. Yeah, search on more specific criteria that may vary based on a category or class. So classes have, multiple purposes. It's not just to, figure out what semantic relations we're going to have. If we define classes, we can focus certain other activities that we're looking for based on classes. Of course, visualization's nice. And I showed you something already, a visualization of semantic relationships. It's kind of to get an overview, an over picture. I mean, it's not, it's concrete, but that's still something you can get with ontologies and taxonomies alone. You just kind of get this tree. It's like, but I want to see the synonyms. And I had to show you 2 screenshots. One was the hierarchies and another one was the controlled vocabulary. And, on ontology, you can get some other interesting visualizations. And then reasoning and inferencing. Those are features of ontologies because ontologies are much more richer semantically and have constraints built into them that you can do that you cannot do with a taxonomy. And of course, build a knowledge graph and applications on that. At some point, ontologies and knowledge graphs were almost synonymous, but they aren't. I remember a while back, if you looked up, I think knowledge graph and Wikipedia sent you to ontologies. Now they know it's not the same thing. So a knowledge graph then, as I see it, or we see we at Semantic Web Company see it, is taxonomy plus ontology plus instance data too. That is stored in a graph database. And then what can you do with a knowledge graph? Because I've told you now what you can do with an ontology is, because now we're bringing in the data. You can search, expand a search to data in different repositories and applications and platforms, because there's that connection and extracting out or making copies of the data. And search and discovery across heterogeneous content and data, both structured and unstructured. Also, I said, applications built on this, often personalization and recommendation systems and visualizations, as I said, and then developed additional AI-based applications. Does anyone else have something to add to this list? Yes? Yeah.
And you might have already addressed this, but when you're looking at you said the equation, taxonomy plus ontology plus instance data.
Yeah.
Why couldn't that just be ontology plus instance data? What is it about taxonomy that?
Well, again, it depends on your definition of ontology. If it's just the semantic layer, then it wouldn't. You need to have all the rich extension of all the topics and, and names, named entities as well. And yeah, but if you have an ontology that's, you can go in both directions. And someone even just posted this to the Knowledge Graph Conference Slack. Well, I've heard about taxonomies extending to ontologies. What about extending ontology to taxonomy? Which you can. It depends maybe on the tool you're using. But one of the reasons I would suggest starting with a taxonomy is because, well, often organizations already have some taxonomies here and there. They don't have an ontology yet. And it's more they're created based on looking and analysis of content and extracting terms from content and talking to people about. So it's not, I think it's more grounded in actual use cases. Whereas an ontology, well, certainly the top level classes, they're based on business and use cases. But as you start getting down deeper and deeper, starting from the top, you might be guessing and, well, we might want this, we might want this, You just keep going, well, yeah, I've seen taxonomies include this, we'll take this other taxonomy include, but then it's not reflecting what's actually within your use case and your organization as much as building from ground up. But that's a good point, that if you define an ontology as all of it, the semantic model and all of the individual concepts and named entities, then it's just ontology plus instance data. Yes?
Can you help me understand what is instance data?
Ah. Yeah, that's a good question. I'm trying to think if I don't have it. No, I don't think I have it here. But it would be any data that could be existing in spreadsheets that you've decided to bring into that's stored in a graph. Basically, that would be stored in the graph database. So you don't have content items. You wouldn't have paragraphs of text or images necessarily. That would be stored somewhere else in maybe a content management system. But I'm using the word, so that's why I'm saying data, not content. Instance meaning, yeah, any specific data. So when we have a people, list of people, then instance data would be, this person's birth date or this person's company, employee ID. That would be examples of instance data or other kind of.
So the class, the description of the class of person with the properties of person.
Yeah, the properties.
That's the ontology.
Mhm.
And then the list of you or me.
Yeah.
With our own birthdays, that's the instance data.
Yeah. So it would be the values of the properties. And a certain, but sometimes it's even how you model it. Is it in the ontology tool, or you can go beyond what you have modeled in your ontology software. Okay, I'm not even talking about PoolParty. It could be Protégé or something like that, where you've got even more data and it's in a graph database and you want to connect to it as well. So the knowledge graph is still more than what's in your ontology management software, because you can connect that to a graph database software that could be external, that already has other data in it. And that together is the knowledge graph. But yeah, go ahead.
Do you see the one set of taxonomy used in the multiple set of ontology? Is there an example for that?
Multiple sets of ontologies or just multiple ontologies?
One set of a taxonomy used in the multiple.
Okay, one
sets.
taxonomy used in multiple ontologies. It could be, yeah. Taxonomies tend to be custom built for each organization and each use case, so they're not being shared a lot. There is one vendor of taxonomies, especially, and we partner with them, called WAND, W-A-N-D. Welcome to look up their website. So they build industry taxonomies, and some of them are, for different verticals. And you can license their taxonomy, and someone else can license their taxonomy. You can put it in your ontology, and they can put it into their ontology. So that would be an example. However, you're probably going to modify the taxonomy you buy from WAND. You're allowed to do that. That's the idea, is it's a base taxonomy. So eventually you're going to change anyway.
Thank you.
Okay. Yeah, what you can do with a knowledge graph. Search expanded to include different repositories. Yes. Now I can't remember if I already said this. I think I did already. Oh, right. And enterprise knowledge graphs are becoming the dominant implementation for business ontologies. That's what I've found. Yes?
So I had a question regarding if you have any rules of thumb for deciding whether a concept would better fit as a taxonomy or an ontology.
Okay. Yeah, it would be as a class or subclass, actually, in ontology. That's a good question. Again, it depends on how you're modeling it, but if you're going to follow the approach where you already have a taxonomy, then what becomes a class? There has to be some business use case reason why it will have its own specific properties, attributes, or custom relations. Now, if they're all inherited down and they're all the same throughout the levels and we don't. But at some point in the hierarchy, it's going to be unique from what's, above it in the class or with others, if that makes sense. But it's sort of letting the properties drive the decision to make something a class. The properties mean the custom relations, the semantic relations, and the attributes. And where you see, you can, again, you could have, let's say for people, you would then have different roles and, professionals and, managers or whatever, or engineers. But do the engineers have different properties than managers or not? It might be, because you might say manager manages people. You created this relationship. Well, then they are separate. But if that relationship is of no use to your business case and you don't need it, then essentially they can be in the same class. They have a different meaning when it comes to tagging content, but when it comes to modeling the ontology, there isn't anything different. Then we'll just leave them as concepts. So you don't have to get down that deep.
Something that you don't need to instantiate. Could
In
be
a certain way, yeah. But it's still relevant for aboutness for tagging content. Okay.
Is a taxonomy a hierarchical relationship of instances of the same class?
Okay, the question.
Or is it, if I have, I'm going to say this is an ontology, if I have a set of classes, disparate classes, but they have parent-child relationships, 3 levels deep, is that the taxonomy as well?
Well, I would say that the hierarchy of classes within an ontology is a kind of taxonomy-like feature of an ontology.
Yeah, but not quite a taxonomy, right?
Yeah, because when I think of taxonomy, I think of something that's standalone to call it a taxonomy.
But it's a hierarchical relationship of instances of the same class, like
Okay, whether they're instances.
like SKOS, for
Yeah.
example.
Oh, well, it's interesting because SKOS is an ontology.
But it's an ontology to describe a taxonomy.
Yes, exactly. Yeah. But instances of the same class or subclass. So if they're all the same class, well, then they're all on the same level. They're not to each other in a hierarchy. Because if they were hierarchy to each other, then they wouldn't be instances. They would be subclasses, right? Right, instances. Yeah, I think of instances like you're very, the most specific that doesn't have any subclasses.
But I think that's exactly what SKOS does. It says that you have relationships between instances of classes that make them form into a taxonomy.
Yeah. Okay.
This is like a chicken and the egg.
I guess, yeah. Sometimes I don't analyze it in that much detail. Great. All right. So, the question about what are the components of what's a knowledge graph and where does taxonomy and ontology fit in? Again, this is everything here. What we want, we have at the bottom the content and data layer. We have content, we have different documents, but we also have data and databases and in spreadsheets. They should have Excel here. This would be a common one. And then extracting or making copies of the data out into store in a graph database. And that's the next, might be virtual data layer. And then the layer of ontologies and taxonomies, controlled metadata, and then a front-end application. So what's actually a knowledge graph is that this layer in between of the instance data, the virtual data that is extracted out of the other sources. And then the ontology and controlled metadata or taxonomies. Actually, I didn't create this slide. I would have written taxonomies here instead of controlled metadata. And that's where, again, the question was, well, what's instance data or not? But it's more about otherwise, so why don't we just call a knowledge graph the ontology and taxonomy? It was this additional instance data that was residing in other databases or spreadsheets or repositories that is extracted and brought in. All right, yeah. Okay, yeah, go back to that.
So imagine that we have multiple perspectives over a taxonomy, right? Which means that I want to make a subset of it, and that could happen between different business units. What is the usual practice and how we look at it or how we store it? Because we try to build a taxonomy to solve a bigger problem,
Oh, yeah.
but there are other sub-problems that don't need the whole system that is there, where I want to contextualize to that one particular section or a particular section that is there.
Okay, yeah, you want having one taxonomy, but you only want parts of it for different.
Or even we can think of
Yeah.
a sub-ontology. Like
Yeah,
I
yeah,
don't
so,
wanna-
or subtaxonomy, that makes sense. There are different approaches. I mean, in SKOS, there is something called collections. It's an optional feature, so you could designate a collection for a certain use case, and that certain concepts belong to a certain collection. And then the other way is actually, you have different, SKOS, the highest level it defines is a concept scheme. SKOS doesn't tell you a taxonomy is a taxonomy a concept scheme, or is a taxonomy a collection of concept schemes? That's up to us to define. So you could have then different concept schemes for different purposes, but manage them together in a certain way. A tool like PoolParty and our competitors will manage something as a project or as a custom scheme or domain or whatever they call it, that can have multiple concept schemes in it. So you're managing it together, and then there are all these tools to kind of compare and see if you have duplicates or not, and you want to bring them together. You could manage as multiple completely separate projects and then link them together with, SKOS also has linking, matching relations. It's called, SKOS exact match or close match or broader match, narrower match, related match, which are designed to be across concept schemes, but they could be managed in different projects. So as I said, there are multiple ways to do it.
Understood, but if you want to go real time, right? As you say, like if you connect knowledge graph to a particular ontology, and then I want to only get a perspective of a knowledge graph, which is defined by constructing the ontology.
Constructing the ontology.
Yeah, which means that imagine the instance data is connected to the full ontology.
Mm-hmm.
Then I want to develop a perspective on top of the knowledge graph, which means that I only want to construct a view. For example, I have CRM data and product data, XYZ data. I'm only want to focus on the CRM data now.
Yeah.
You create it
Well, as I said, there are different ways to define that. I mean, even like you say, with the SKOS collections or with different concept schemes, with the ontologies, you could manage it as, with ontologies, you can manage them as separate and also connect them and link them together too. So you may want to designate these as separate ontologies and then link them.
Okay, we'll discuss later.
Yeah, we can discuss later. All right. So to summarize that, we have a knowledge graph with the extracted data that's stored in a graph database. And there are RDF triple stores or labeled property graphs are the two different kinds. In a very simple knowledge graph, it could actually be stored in a search index. And this would be an RDF triple store based one. And then these are then linked with metadata and control vocabularies, especially on taxonomies, and then these are connected with an ontology. With the relation, sometimes people have even said, is an ontology is to connect multiple taxonomies together. I've actually heard people say that. Well, yes, I mean, that's not the only way an ontology is used, but that's one possible way to do it. And then this was sort of related to that question about what is instance data. So what kind of data is included versus not? I think this is actually where I was what's the difference between data and content? So no, that wasn't exactly the same question. So I've already explained that the instance data was not the data that would normally be as just attributes or instances in the ontology, but they came out of a graph database. But then you want to link more, everything. So here is what's like the definition between data and content, because content definitely does not reside in the knowledge graph. It's connecting to it, and it resides in some form of a content management system. All right, so I have this brief comparison of the two kinds of graph databases here. So the RDF, that's, of course, the World Wide Web Consortium is responsible for the semantic web, web standards and semantic web standards. And RDF, and I'll explain the standards in other, is coming from the World Wide Web Consortium, where it's labeled property graphs. Each vendor has kind of does their own. It's not based on RDF standards. But the RDF triple store is more the focus on the goals of the W3C, that linked data, linked open data, the semantics and interoperability. The labeled property graph, I mean, the goal is, all right, this is going to be much more efficient and much faster than relational graph databases. No, relational databases, not graph data, the relation database management system. So it's the graph traversal and path search and serialization and all that, really focus on the shortest path calculations. So they might say that in the really large implementations, a labeled property graph might be faster than an RDF triple store. But we get these other benefits of the inferencing and the linking and more of a data-driven and metadata management. And when we're talking about taxonomies and ontologies, they fit in better with the RDF triple store because the taxonomies and ontologies are also built on RDF, which is what my next slide here is for. So RDF triple store graph databases store data, they store links to content, and they also store the metadata, the control vocabularies, the taxonomies and ontologies, because the taxonomies and ontologies are also built on RDF. So RDF, Resource Description Framework, it's a World Wide Web Consortium standard or recommendation, a standard model for data interchange on the web. I mean, it is quite basic, and it just requires that everything has URIs to specify the things and the relations as well, and models everything in the predicate subject, or in the triples of subject, predicate, object. And remember, we said an ontology is based on these statements as well. Another way to look at, again, taxonomies versus ontologies. So knowledge graph components can talk about instance assertions, A box, and terminology definitions, schema, T box. And I've heard more recently, this comes like the idea of taxonomies as being categories. And since the T was already taken for T box, for terminology, we can call those C box. And so a knowledge base or a knowledge graph is, again, built on A box, T box, and C box. And this, of course, is not my idea. It comes from Dave McComb, who works, he runs Semantic Arts. He came to this conference before. And so this table, this graph is actually from him. But again, he and his consulting, and Semantic Arts is an ontology consulting company. That's what they really focus on. That he was also proposing that we have data and the ontology and taxonomy and instance concepts as well. So here, key concepts means actually ontologies. It doesn't have to necessarily that ontology has hundreds of classes. Really big ones do, but they may have only tens. Whereas the taxonomies, and then there we often, taxonomies will have thousands of concepts. And we won't get into the data, hundreds of thousands. And then you put them all in triples, you get millions. Okay, any questions at this point? All right, so I've kind of touched on standards. I want to get a little more deeper into them and the features of taxonomies and ontologies. And these come from the World Wide Web Consortium. So they're both based on RDF, Resource Description Framework, which I've already explained. So then ontologies, there's also RDF schema or RDFS, which goes beyond RDF for representing vocabularies by explaining classes and properties. And then OWL, which is Web Ontology Language. I know the acronym isn't exact, but that's it's it's easier to say OWL, is actually semantic web language. So it goes beyond just being a standard. It's even more descriptive to explain the features of ontologies, and it's based on RDF and RDFS. And it is quite extensive, the whole OWL guidelines. If you go to this page, there's a lot there. And then taxonomies and control vocabularies. I mentioned SKOS. This is Simple Knowledge Organization System. And it, after RDF was developed, and then we got OWL for ontologies, well, what about these other control vocabularies? So remember I said KOS, Knowledge Organization Systems. And where an ontology isn't quite that, it's because it's knowledge representation. So it's for taxonomies, thesauri, classification systems, terminologies, that they can also be, their data can also be shared on the web. And the encoding has used XML, now also JSON, and it's based on RDF for publishing these, but also allowing the linked data. That's also always part of it. So my didn't come up. Looking a little bit more into how OWL defines the components of ontologies. Now, I've been talking about the three things: classes, relations, and attributes. But actually, OWL explains it not in a slightly different way, and they're different things. So they're entities, and more fundamentally, entities include classes and individuals. And individuals and instances, I think, are the same thing. Does anybody have a reason to say they're different? All right. But the individuals are members or instances of a class or a subclass. And the classes are groups, and they contain individuals or they contain subclasses. So then when I talked about relations and attributes, both of those are considered properties. What's significant is that the properties are the predicates in the triples, and the classes are what's on either side. What's the subject of them? Okay, so and then they're defined as object properties, which are relationships, the semantic relationships, and data type properties, which are the attributes. And that's where the value of an attribute is just a literal. That does not have a URI. It's just a lexical form. Now, there are a few other features about ontologies. I mean, if you're familiar with them, you know all about this. But so yeah, URIs are actually IRIs. Everything has an identifier, and they're different syntaxes. So RDF XML or OWL XML. There's also Manchester syntax. So you can actually go beyond just RDF. And there are other features, as I said, not just what I showed you on the previous page about individuals and entities and classes and relations. You can specify this class disjointness, something can only belong, the classes are mutually exclusive. Or you can create complex classes and hierarchies of properties, not just hierarchies of classes where it's class, subclass. You can also have sub-relations and sub-attributes and property restrictions, that certain properties can belong to only certain classes, and cardinality restrictions about can you use it, is this only used once or with multiple classes or other things. And domain and range restrictions. So in a triple, the domain is the subject and the range is the predicate. And so you can restrict either of those or both. Equality or inequality of individuals, how many individuals and other data types, and also supporting reasoning and inferencing. So you can see this gets quite rich and complex, and all this doesn't really have anything to do with taxonomies. Taxonomies don't do any of this. So, all right, I've explained pretty much the overall high-level features and standards for ontologies. Now moving on to taxonomies and other control vocabularies that are similar, like thesauri. So SKOS, which I've referred to several times, Simple Knowledge Organization Systems, as a data model. So the word standard isn't maybe quite right. It's maybe better to say a recommended data model from the World Wide Web Consortium that first came out in 2004 and was really kind of revised and in its published form in 2009. So taxonomies have been around longer than the existence of SKOS. And then we kind of came around, oh, let's adapt our taxonomies to SKOS. So it's considered a common data model for sharing and linking knowledge organizations systems on the web. But just like other web standards from the W3C, it's not just for the public web, because many organizations have brought web standards inside the firewall, or there are all these web-based applications. So those web standards are really common everywhere, not just the public web. So even if your taxonomy isn't intended to be public, you would still want to have it built on this standard, because then you can import other taxonomies and link them, and you can at least, the import and export and sharing, and illegally sharing with your partners or your vendors, not necessarily publicly. A knowledge organization built on SKOS is machine readable and interchangeable. As I mentioned, encoding in RDF and XML and other methods. It enables easy publication use of vocabularies as linked data. And I had talked before about that linked relating. It's not just relations within the same taxonomy, but these matching links to other taxonomies that could be not even on your server, but out on the web as well. But it supports different kinds of knowledge organization systems. I said not just taxonomy, all the ones I had in my list: name authority, thesaurus, and ontology in a certain way by extension. All right. So this is SKOS. Right? Remember, the S is simple, means simple, so it's not too complex. These are all the elements in SKOS. And they're kind of grouped in this way. The highest level is concept scheme, and I mentioned collection is an option, and then you can have members of a collection. And then concepts, that's what it's based on, not terms, not strings, they're concepts. There's also a designation of top concept, and the rest are just any concepts. Then the labels, pref label is the preferred label, and then there's alt label, alternative label, and hidden label. Notation is for a numeric code if you wanted to create a classification system with codes. Again, it's not used that much. And then the various notes for documenting, that scope note definition example, and then also notes for maintenance and history purposes. It's a change note, editorial note, history note. You can add notes of those types. And then the relations. It says here semantic relations, but they're not very semantic. It's just broader, narrower, and related. I like to say semantic relations when I'm talking about ontologies. And those mapping or matching relations, which is across different taxonomies, which could be exact, close. I like to say exact means, it's either the same word or it's a definitely agreed upon synonym, whereas close match is, it's good enough for the context, but it might not be sufficient in somebody else's taxonomy. And then broader, narrower, and related is really when you want to take one taxonomy and another and not completely merge them, but connect them, and then something's broader and narrower or related to something else in the other taxonomy, because it is about linking them. Okay, so I kind of came up with this comparing of ontologies and taxonomies and control vocabularies, because they do have certain features. So ontologies do have a hierarchy of subclasses. And this corresponds to the hierarchical relationship in a taxonomy of generic specific, where you can say is a, the narrower the subclass is a broader or parent class. And class disjointness, that is, taxonomies, you should have unique concepts. In ontologies, we have instances. It's not really defined as well, but they might be called named entities or a name authority. Ontologies have annotations, and that's pretty broad about how you use it. And then taxonomies do have those actually more concrete, specific types of notes. As I said, change note, historical note, scope note, and definition, and all that. But where they differ, I showed that ontologies have a lot of features that taxonomies have. Sounds great, then why do we need to make a separate taxonomy, right? Unless there one thing exists. There are some features that taxonomies and control vocabularies have that ontologies don't. And this is, having multiple labels for the same concept You can have multiple alternative labels, designate hidden labels, and labels in other languages, which could be a preferred label in another language, and multiple alternative labels in multiple different languages, and multiple hidden labels, and multiple, this is very rich in that multiple label type of thing, where we don't see that in ontologies. Some people have thought, okay, in ontologies, now there's something called same as. That means equivalent, right? Well, that's really meant to meaning it's the same in another ontology for linking ontologies. It's not within the same knowledge organization system. And then with the hierarchical relations, taxonomies borrow here now from the thesaurus standard. So it's not just generic specific class, subclass, is up. There's another kind that's whole part. This is where something is part of some, the narrower is part of something bigger. This, of course, applies to geospatial, anything geographic. It's then a city is narrower to a country, is narrower to a continent, or something like that. And even generic instance is considered a hierarchical relationship, not a member of a class. Okay, the various types of notes and definitions. As I said, we have some documentation. It's much richer in those types of notes. And even the designation of something called the top concept. You might want to use that. And collections, so that's a feature as well, or mapping across different concept schemes. All right, any questions or comments at this point? All right. Okay, so different kinds of ontologies and approaches to building ontologies. Often people talk about the more generic upper ontology or foundation tax ontology. It's sort of top level versus domain that's subject specific or maybe even a use case specific. So the upper is very, very generic. In fact, that's where SKOS itself is an upper level ontology. Some of them, it's basic formal ontology and suggested upper merged ontology and general formal ontology. GIST is actually developed by that ontology consulting company, Semantic Arts, as being a kind of, and it's good. It's sort of more like practical, more industry focused, let's say, not academic. And then domain ontologies are, specific subject domain. Of course, they're definitely those that are in biomedical sciences and gene ontology, and one that's in business, the financial industry business ontology, FIBO is often referred to. And I've seen, financial services industry is going to take that and try to do something with it. Say try, I don't know. But actually, there's a continuum from how, generic or specific your ontology is. It's not like it's one or the other. But the idea is that maybe you start with a foundational one and get more specific. I wouldn't necessarily advocate that, but that's sort of the original idea. All right, if we look at them, how they're kind of, one way, we don't have maybe the best visualization of ontologies in PoolParty, but we list our classes and our relations and our attributes, because you don't have to be an ontologist to create ontologies in PoolParty. It's kind of simple. So an upper ontology is not, it says, although it's more basic, you'd think it's smaller. It doesn't even have to be smaller, but it's more generic. And it's intended to be extended further, whereas a domain ontology could be extended too. So on the left, I have here an upper ontology example, org. So it's meant for any organizations. And we have, agent and as a class, and change event, membership, post, role, site. They're very generic. And then we have all these kind of relations of, holds by, location, member, base stat, changed by, and so forth, and attributes of identifier and purpose. So it's pretty generic, although it's, I would say this one isn't, the size is maybe kind of average. And then I have a domain ontology example. It's more specific. This one has to do with astronomy. So just so you get the idea what domain specific ontology is compared to a very generic upper level ontology. So we have classes for asteroid, comet, compound element, mission, moon, person, place, planet, program, spacecraft, star. You can see how this is really specific. And then the relationships of has discovered, has moon, moon of, and attributes. Again, when you go into each of these, you'll see how they're related. But just to give you an idea, yeah.
Any reason why they chose to visually represent the ontology as a kind of a taxonomy form as opposed to in a model form?
Well, this is kind of at the high level. Then you can go in and select the relation, and you see what its domain and range is, or the classes. So it's sort of it's really a list form. I mean, this is one visualization. There are others too, and I chose to show this one at this point because it just gives you an overview of how detailed it is, how many classes and how specific they are, how many relations and how specific they are. That answers it. Okay, so ontology creation approaches, and this is, we will focus on the top down, taking your ontology and classes and building more specific subclasses, and versus the bottom up approach. So the top down would be that you start with a foundation ontology, select the most appropriate one, and then extend it by adding specific subclasses, and then and other subproperties, the semantic relations and the attributes, and then further on links to individuals. And this would be done in a single system. The ontology then comprises all the entities, classes, subclasses, and instances, although not the instance data that comes out of the graph database, other databases. So in this case, an ontology built this way would be as detailed as any taxonomy. But again, you don't have some of those features that a SKOS-based taxonomy has with that rich relations and, rich labels and other notations. So classes of multiple subclasses and the individuals for the unique entities. And this would be modeled in a tool such as Protégé. Okay. How many of you are familiar with Protégé? Okay. I played around with it, but I haven't built. Here is it. Okay, FIBO, I gave as an example, the Financial Industry Business Ontology. And you can see here, these are screenshots from Web Protégé, which I've used. You see many levels of class hierarchy: thing, agreement, contract, credit agreement, debit instrument, and then non-tradable debt instrument, and variable income security. It's getting that specific all in the classes. And so there's the classes, and then we have properties, which in this case are the object type properties, the relations, acts on, authorizes, and advises as managing member. So again, very deep, extensive relations. And then the properties that are the data type properties, which are attributes of having address, address line 1, address line 2, address line 3, and population, all these details. Oh yeah, then the instances, the individuals. So these are the names of individual Federal Reserve Bank, Federal Reserve 4th District, Federal Reserve 9th District. Those are examples of individuals. Okay, based on jurisdiction. All right. And then the bottom-up approach is starting with taxonomies, or even further back, let's back it up, data sources and taxonomies. Starting with existing taxonomies and control vocabularies, select what's needed, and migrate them and import them into a single URI namespace so that you're creating your single taxonomy project there. And this would be based in SKOS. And then each vocabulary could be a concept scheme. So you could have a concept scheme for names of people, another concept scheme for names of organizations or departments, another concept scheme for whatever, geographic places, another one for activities, or another one for products and services. Maybe you need to build more. And then you model the ontology from that. How do these different concept schemes, it's often concept schemes would be your classes. Now you might get deeper a little bit into subclasses, and it doesn't have to be one-to-one, but that is a good place to start. And then you can apply the ontology classes to the appropriate concept schemes or maybe top concepts. So then something as a concept would exist, or a top concept or a concept scheme exists as that, as a top concept or concept scheme, and it also exists as a class. So yeah, the bottom up from taxonomy sources. The ontology then, what's modeled as a ontology includes the classes and subclasses only to the extent needed to describe the generic characteristics of the model. That means based on they have properties that need to be defined for the business model, that, whether they're semantic relations or attributes. The ontology does not include all levels of the hierarchy nor all instances. Those reside in the SKOS concept schemes. And the ontology is a model that is applied as a semantic layer then to the taxonomy or multiple taxonomies. I mean, still, we don't know what is one taxonomy or not. That's why I'm saying maybe it makes sense as, multiple concept schemes. And then more of the hierarchy actually resides in the SKOS taxonomy or taxonomies. And then together, they're modeled in combination. That's where, in a taxonomy/ontology management tool instead of Protégé, and that would be PoolParty and our competitors. They do the same thing. We're not the only ones. Any questions here? Let's see. Let's look at an example. Okay, so variant on our astronomy here. Apollo missions, the moon missions. So I have here, of course, is a hierarchy, a SKOS-based taxonomy. Apollo, it's the whole project, and we have what's in purple are the concept schemes: astronauts, missions, sites, vehicles, and I have another screenshot where I've expanded the list of astronauts, where you actually see those are named entities, of course, names of people. But we actually have concepts, whether they're classes. It's interesting. Missions and top concept manned missions, which is a concept, and then we have names of entities under that. Even the Apollo, each one of those is a named entity. Or sites, we have launch sites and moon sites. Again, those are generic taxonomy concepts, and we've got named entities under that. Now, in the ontology, again, I know this isn't a nice graphical ontology, but I've just got here my list of classes, subclasses, list of relations, and any subproperty relations, and list of attributes. So the classes pretty much follow the concept schemes, and I put it in this convention is to put those in singular and put your taxonomy concept schemes and concepts in plural. That's why at least I can keep them straight when they match the same. Astronaut is a class, astronauts is a concept scheme, and mission and site. I do have a subclass of lunar site, which matches our top concept in the green here, moon sites. One's called lunar site, one's called moon site. You can call it something different. Because it does have certain properties. A lunar site is different from a launch site when it comes to certain properties. And then the relations, and we also has, the missions have members, but then commanded by is a sub relation, because only some people, all these people are members, but only some of them are commanders of the missions of which they are members. There was a lot of commanded by. And then the attributes for everything as well. So, in another example here. So you create, the taxonomy and create the ontology and link them together. The ontology then tends to be smaller and has fewer classes than your, taxonomy, which could have a lot of hierarchy. And the taxonomy is generally based in SKOS and the ontology in OWL, but they're all compatible on RDF. Okay, you had a question?
Yeah, how come the names of astronauts shouldn't that be an instance data where you just link to a class? Or is it in the taxonomy?
Well, I've chosen to put them in this whole approach is I've chosen to put them in SKOS, in the taxonomy management feature or part of my taxonomy/ontology tool. And so the ontology area does not include any instances. All of them are. And what's interesting about this is in an ontology, you know, you got all these subclasses, you get very specific. When does it stop being a subclass? When is it an instance? What's the difference? And what's interesting, well, I have a different example here with food, but when we had our space things, vehicle, launch vehicles, let's say the Saturn rockets, something like that. Those are the moon rockets were called Saturn rockets. Is that an individual or not? Now you say, well, it's a proper noun, it's a capital S. You know, in taxonomy, we say, yeah, that's one of our named entities. But no, there were multiple Saturn rockets. There were individual ones, you know, especially when it comes to a product, you know, where there could be a brand name, but, you know, like this is a MacBook Pro here, but somebody else has a MacBook Pro. This is not an individual, right? Each is an individual. Or the brand, the brand is not an individual. The brand is a brand name. But in a taxonomy, that's considered a named entity. So sometimes it gets a little esoteric trying to define what's what. So we don't even have to worry about it. We're just putting everything that's more specific than needs to be modeled in an ontology. Oh yeah, so actually here I drew the lines here, this other one. So this is an example. If we had this recipes, let's say it was a website to search recipes, and you can have these as facets or filters. So I want to limit by cooking method of grilling and a dish that's an appetizer, a grilled appetizer. That sounds good, and it, you know, has some main ingredient of some vegetable or whatever, and that's how your traditional taxonomy with the concept schemes working as facets. But if you wanted to look at it differently and find, instead of I'm looking for recipes only, but I wanted to find which ingredients are, you know, best for grilling and which, you know, cooking method tends to go with this, which occasion, and which ingredient tends to go with which, you know, you're coming in all these different directions. Okay, I want to make an ontology instead. And then you don't, that's where, you know, you then designate classes and relations. So we could say that the cooking method is for cooking a certain dish, and the dish has an ingredient. The ingredient is included in the dish, and the dish is prepared or served on a certain occasion. And so that's where we've kind of changed it from a simple faceted taxonomy to ontology, where we can make these different links across. So, yeah. Okay, we're still talking about ontology creation approaches. They said, I mean, yeah, I would take your question.
You might get into this, but where do you draw the line between attribute and relation? So, like, if you go back to the astronaut example, one of the attributes was birthday. But you could also say has birthday equals whatever.
Oh, yeah.
Triple. So where do you draw the line?
That's good. I think, yeah, well, if you want, birthday, and again, if it's numeric, I wouldn't. But if it has something to do with,
I think if you have a time tree.
yeah, no, it's really when you decide. A good example would be with location. You know, you could say birthplace.
Yep.
That would be a better example. Here it's an attribute. So I could just put in any city or whatever. Or do you want to control vocabulary that's geographic and linked to it? That location is often, it can go either way. So one of the criteria is thinking, well, is there going to be a reason that people want to look up everybody that was born in this location? Or is this location going to be used for other purposes too? If it's only going to be used for the birthplace of astronauts, and there's really no reason that anyone would want to look up all the astronauts born in this birth location, then there's no need to have it as a class and a relation property as opposed to attribute. But in another taxonomy, sure, location might be important, and we want to look up if there's something with, you know, my first model of companies and locations and employees. I then did have location as a geographic location because I was interested. I want to know what companies are located here. I'm going to make a trip here. There's a conference here. I want to know if one of my other customers or partners are located here or something like that. Okay. Oh yeah, so because we were talking about going in different directions, maybe you want to import taxonomies into an ontology management tool like Protégé and connect them that way. And I don't recommend that, not merely because I'm a vendor of something going the other direction, but in a taxonomy, I remembered, okay, there's the most common hierarchy. Of course, a taxonomy is based on hierarchical relationship, but most of them tend to be the generic specific ISA that would convert to a class subclass. But there is also the whole part, which I said could be with geographic or other things. And those would then also convert to class subclass. Now, to say, so in a taxonomy, New York City would have broader, New York State would have broader United States. In a taxonomy, that's fine. But New York City is not a subclass of New York State. New York State is not a subclass of the United States. But that's what would happen if you actually imported a taxonomy into an ontology tool. And then even the individual instances, like those names of those astronauts, those are also narrower. They were a narrower concept in the hierarchy in the taxonomy to astronauts. And of course, they shouldn't be converted into subclasses. They should be converted to members, individual members of a class. So that's what would happen if you imported it. So I said the whole part in generic instance. And also all those wonderful alternative labels, they would just get imported as annotations, which aren't very useful because the whole use of those alternative labels is to support the search strings and auto tagging and all that are great benefits with taxonomies. So this is kind of then summing it up here. I just want to show here the taxonomy and the ontology layer. So we have a domain taxonomy of recipes. And then we, extend it with the ontology. And it's a small ontology. We have only 4 classes, 6 relations, and 2 attributes. Is that really an ontology? Well, we call them custom schemes in PoolParty because it's actually it is a scheme and it's custom. It's this very simple basic ontology. And this is actually how it would look in our tools. That concepts have both SKOS relations and properties. So you see here SKOS. Again, we have our dishes and desserts and fruitcakes, and SKOS has a broader, narrow, related, preferred label. But then you see here this recipe scheme. So this is our custom scheme based on the ontology. And then what we can bring in here are these custom relations. For occasion. What occasion is it for? And what does it go with? Actually, goes with is one of those relations that's bidirectional, the same. It's not an inverse, but it's not the same as related term or related concept. It's more specific. It goes with. Fruitcakes go with chocolate cakes and whipped cream, and has main ingredient, and is dried fruit, and is prepared by baking. And you can see that even these, I did not restrict to unique. You could add more. And then properties that are attributes, I decided, would be number of calories, preparation time, and served, in this case, room temperature. So that, and the dish here means the class that's been applied to it. So that's an example, enriching the SKOS taxonomy to become an ontology in a simple way. So the ontology class labels tend to correspond and match to the SKOS concept schemes. The ontology layer is actually not really a hierarchical layer because we are matching the classes to existing concept schemes and classes. And as I said, we might consider using singular for ontology classes and plural for SKOS concept names that are otherwise the same. And you don't have this dilemma of determining whether an entity is an individual or instance, right? Especially when we got into products and things like that. Okay, I'm done. I think this is, yeah, that's telling me that the time is up. I did want to show, I mean, I have a few more, how many slides here? All right, well, you asked a lot of good questions, so, but this is a little bit more about how it's done in PoolParty, so I don't really have to get into that, as much. And you will have access to these slides as well. And then I do want to still say the benefits, though, that it makes it easier to use existing taxonomies or multiple taxonomies, because many organizations already have some taxonomies kicking around. And I think it's a little easier to model the ontology. I don't consider myself an ontologist. I consider myself a taxonomist, but I can make ontologies like this. But it also supports expert specialization. You got your taxonomists work on taxonomy, ontologists work on the ontology part. The ontologists don't have to go down into all those levels of subclasses of a taxonomy that they may not really care to do anyway. It's more flexible and adaptable because taxonomies change more frequently than ontologies. The ontology knowledge model is a little more stable. We're constantly adding more concepts to taxonomy and changing them. And they're different purposes. Ontology is more for the modeling, reasoning, and analysis, and the taxonomy is for tagging and information retrieval. So it's nice to have them modeled a little bit separately. Okay. Okay, I think that's it. I think I've kind of, oh, right, there was another example with the cocktails and how it's modeled as well, because we have all this cocktail scheme of what it consists of. And this is looks like a faceted search, but what you can see here is that we can start with ingredient, cocktail, garnish, or drinkware. You can start from any point, and then it depends on what it is, because if I've selected cocktail, I get facets that are based on relationships. I know this is probably too hard to see, but you'll get the slides anyway. Consists of, is part of, is used by, is a variant of, uses drinkware, and uses garnish. Those aren't normal facets. Those are based on the semantic relations. And then selecting from ingredients is part of drink. You can start with ingredients and find out what drinks are made from it. Okay. So conclusions, extending a taxonomy being an ontology provides more uses than a taxonomy or ontology alone. Both of them have good benefits. Makes use of existing taxonomies, can conform to both taxonomy and ontology standards for interoperability, if you start with your taxonomy and SKOS, and is best done in a combined taxonomy management tool based on semantic web standards. And I have some sources here on taxonomies and ontologies and learning more. And that's me there. Okay. And I have a few copies of my book that I'm selling at our PoolParty booth. Okay. Thank you very much.